Kia ora and welcome to this first video in this new series, Agile Algebra. I hope you find the series here really useful in improving your algebra skills in unfamiliar contexts. Let's crack on to the first question. We've got a relation here, an equation with x's and y's in it, and the graph is shown below. It's an ellipse, a tilted one, and you're looking at finding the minimum and maximum values of a quantity. It looks like an optimization problem, but in fact you can use algebra to solve this. Pause the video now, give it a crack, and then afterwards, after the intro music, we'll go through the solution. Okay, for this question, we've got a multivariable function. X and y need to satisfy this one equation. So of course there's an infinite number of pairs of x and y that lie on the curve shown. The curve is a tilted ellipse. You're not expected to know that, but when you have an equation with x squareds and y squareds in it, it could be an ellipse or a hyperbola. Find the maximum and minimum values of y over x. So what you need to realize is that this expression that we're trying to optimize, if we call it a different letter, let's say m equals y over x. Now that there is slope, okay? Y and x, if we think of it as the distance from the origin, then we're looking at the slope of a line like this or like that. Okay, the maximum slope will be the maximum change in y over change in x, which is going to be corresponding to that coordinate there on the ellipse. And then likewise, the minimum slope will be the tangent with the lowest slope. Okay, so the y over x thing is the key connection there. So what we can do is we can consider the equation y equals mx, which is a line with a slope of m, and we can solve that simultaneously with the ellipse equation. Okay, if we solve that simultaneously, we're looking for a discriminant problem where we make the discriminant equal to 0. So if I substitute the mx, the y equals mx into wherever there's a y, and then what I want to do from there is simplify it. Okay, it's a quadratic expression because we can see that there's an x squared there, there's another x squared here, there's an x squared in that one. So they are the three terms that make up a quadratic. So we have 2 plus m plus 3m squared all multiplied by x squared. And then the linear term, so we're going to go hunting for that one. We've got a linear expression here, and we've got another linear expression there. So we can factor out the minus. We've got minus 11 plus 20m times x, and then the constant term on its own, 40. And because we're looking for the max and minimum slopes, we're looking for the tangents. So discriminant equals 0. It's a little disguised discriminant problem there. 11 plus 20m is the b squared minus 4 times a times c. Okay, so that, remember, is this dude here is my a, this dude is my b, that's my c. Okay, now I've got another quadratic equation, this time in m. If I simplify that quadratic equation, it simplifies down to that, which doesn't have nice solutions to it. So we get two values of m. We get m equals 2.5083, or m is equal to 0.9917. And we can test both those values because we look back at the picture there and we go, okay, that first slope here looks like it has a slope of about 2, so a number close to 2 makes sense. and then the other one has a slope of about 1, and this line here looks like it's got about a slope of 1. Better to just use Desmos and substitute the equation of the ellipse, graph the equation of the ellipse and then graph the two straight lines over it in there to check your answers. Okay, hopefully you found that problem okay.